Example. So if they write it as f closed dot g, if it's a closed dot, that means multiplication. If it's an open dot, it means something totally different, which we're going to learn tomorrow. It means composition. So if it's a closed dot, that's multiplication. So just like when we had f plus g of x or f minus g of x, we rewrote it as f of x plus g of x or f of x minus g of x. Same thing here. If it's f times g of x, we rewrite it as this. Oh, awesome. Still blinking. All right. So you rewrite it like that. The marker. So if we have x plus 3 as f of x and g of x is 2x minus 1, and they want us to find h of x, which is f of x times g of x, we're going to do x plus 3 times 2x minus 1, and we get a parabola, right? Now, it's the same thing as what we did on Friday or Thursday. I can't remember which day we did it on. But you keep the x's and you do the operations to the y's, right? So you need the same x. So if we had h of x equals this, or f of x equals x plus 3 and g of x equals this, we'd pick f of 2 and g of 2. So we'd pick the same x's and then just do the operations to the y's, and it would get us our new point, correct? So if we look down here, if we do, say, we have to do f times g. So f at negative 2 is 1, and g at negative 2 is negative 5, and 1 times negative 5 is negative 5, so we get our new point, right? And then we do, say we could go here and at 0. So if we went to 0, f at 0 is 3, and g at 0 is negative 1, and 3 times negative 1 is negative 3. And we get all of our points, just like we did with the addition and subtraction. No difference, right? Except instead of adding f of x and g of x, the y's, or subtracting the y's, you're going to now multiply the y's. Okay? Make sense? Get your thing. Now, division is a little bit more difficult because division gets you NPVs. It gets you non-permissible values, and often it gets you a rational graph, right? A graph where there's asymptotes, because you're going to have variables in the denominator now. So if we look at this one over here, if they write it as f divided by g of x, you're going to rewrite it like this. Now, f of x is 3x minus 1, and g of x is x squared minus x. So remember, with addition, it didn't matter if you accidentally messed up the order, right, of which graph you multiplied by which. Wouldn't mess up either with multiplication. But subtraction and division, it matters which one you do. You actually have to make sure that you do f divided by g or f minus g, right? Okay. So we have 3x minus 1 over x squared minus x. What does that look like? That looks like a rational. That's why we do rational unit before we do this, because you're going to have to be able to draw the rational graph, right? So we have 3x minus 1 in the numerator, and we have x and x minus 1 in the denominator. Do any of the denominators cancel off with the numerators? No, so we have no points of discontinuity. We have two vertical asymptotes. The vertical asymptotes are at x equals 0 and 1. And we have a horizontal asymptote at y equals 0. Why is that? If you look back at this version, the numerator is a smaller degree than the denominator. And if the numerator is a smaller degree than the denominator, then you get y equals 0. Okay? Now, how could you do it? So you just go and you sketch it just like we did before in rationals. But how would you do it if you were given the two graphs and not the equations of it, right? So if you were given 3x minus 1 and x squared minus x. So we'd have to do f divided by g. So actually, wherever g is 0, wherever g has a y of 0, we're going to get an asymptote. Why is that? Wherever the g has a y of 0. We're doing f divided by g. And what happens when you divide by 0? It's undefined. And what happens when it's undefined? You get an asymptote. Okay? So whenever you do division, you're going to look for when this denominator graph has a y of 0. Because wherever that denominator graph has a y of 0, you're going to get a vertical asymptote. So right here, I got a vertical asymptote. Well, why is that? Because if I did f at 1 is 2, g at 1 is 0. What's 2 divided by 0? Undefined, so you get an asymptote. Right? And then our other asymptote is here. Why is that? Because f is -1, g is 0. What's -1 divided by 0? Undefined. So we have our other asymptote here. Make sense? We know we have this asymptote here just based on our rules. And then you would use the rest of the graph to find it, figure it out. Okay? We're not going to do it all on this graph. It's just an example. We'll do it on the graphs and some examples later, which are more spread out and not as confusing. Okay. So the domain of a product or a quotient of a function. So the domain of an adding and subtracting was the common domain between the two functions, right? The domain of the adding and subtracting. The range, you actually had to figure it out and then look at the range of the new graph, right? The domain of the product or quotient of the functions is the domain in common to the original function. So it's the same thing. Why is that? Because you can only find, remember what we did on Friday, what we did was you can, or on Thursday, what we did was you could only, when you went to go draw the graphs from two graphs, you could only draw the graph where the two graphs existed, right? If one graph stopped here and the other one kept going over here, we had to draw them only from where this one existed and on. So that's why the domain is only ever between the common amount, because you can only find it when you have two y's that are on the same x, right? So if we were looking over here, but the graph started over here, we wouldn't even have a y for that function, so we couldn't find it. So that's why the domain is always the common of the two, when it's either adding, subtracting, multiplying, or dividing. Okay? The domain of the quotient of the functions must have the restrictions that the divisor has. So this is the other catch, but you have to still state restrictions. So if it's division, you always just look at your denominator, right? And if there's any variables in the denominator, you have to state x can't equal those values because it's MPVs, just like you did with rationals. And then the range of the combined function can be determined using its graph. So you have to graph it and look where the range is. So let's look at a couple equations. So it says determine h of x if f of x times g of x and k of x is f of x divided by g of x for each pair of the functions. So h of x is going to be f of x, so 2x minus 1, divided by 2x minus 3. Yep. Oh. It's annoying. Okay, 2x minus 1 times 2x minus 3. So you could leave it like that technically, but they're probably going to put it together and FOIL it. So we're going to get 4x squared minus 6x minus 2x plus 3. So it's 4x squared minus 8x plus 3. And then the division would be f divided by g. And then you're done. Some people try and cross the 2's and the x's off, and they're like, oh, it's -1/3. No, you can't do that. 2x minus 1 is going nowhere unless there's a 2x minus 1 in the denominator. And 2x minus 3 is going nowhere unless there's a 2x minus 3 in the numerator. Is there? No. So that's good again. We're going to go past B, and we're going to go to C. So h of x is the multiplication. So it's just square root 4 minus x times 5x minus 1. The square root of 4x minus 1 is a monomial, so you could distribute it in. No, I forgot my markers don't change. So you'd get h of x equals 5x square root 4 minus x minus 1 square root 4 minus x. Would there be restrictions on the domain on this one? When you have a square root, you're going to have restrictions. unless that square root is like x squared or something, because it can never, that will never be negative, right? Bless you. So you'd go 4 minus x has to be greater than or equal to 0. So 4 is greater than or equal to x, or x is less than or equal to 4. And the domain of the line is XER, right? So the where they're in common is x is less than or equal to 4. I could have solved it this way. I could have moved the 4 over and went like this. And then when I divided by -1, what would happen? The sign would flip. So you'd get the same answer. Okay? And then this one is just square root 4 minus x and 5x minus 1. So this one would have to be x is less than or equal to 4. But what else do we have? Our non-permissible value. X can't equal 1/5. Now you have to check, because sometimes the restricted domain, because of the radical, actually kicks out the NPV anyways. So if it had been like x is less than or equal to -4, and your NPV was x can't equal 1/5, well, if x had to be less than or equal to -4, 1/5's out of there anyway, so you wouldn't have to state it, right? Because you wouldn't be able to get it. So these ones here actually have values for x, correct? And remember, if it's written like this, we're going to still rewrite it. We're going to rewrite it as f of -1 times g of -1. So what's f of -1? Looks like -4 times g of -1, 5. So your answer is -20. So if I actually went to draw, like remember, that's actually a coordinate. That coordinate is at -1 and -20 if I went to draw it. But my answer to this question is just -20. It's not the point. F divided by g of 1. So that's going to be f of 1 divided by g of 1. F of 1 is 2 divided by g of 1, which is -3. Done. Now, if I did f divided by g, let's think about this. If I did f divided by g, I'd actually have asymptotes. If it was f divided by g, don't draw this, just pay attention. I'd have asymptotes here, because g is 0 here, and here, if I did f divided by g. We agree? If I did g divided by f, would I have asymptotes in the same spot? If I did g divided by f, if I did g divided by f, I would look where f passes through the x-axis, which is here. And that would be my asymptote. Okay? So it depends on what's in the denominator where you're going to get your asymptote. All right. Now we're going to do sketch. And then we're basically done. Oh, we have to do one more thing. So f of x times g of x. So if I want to draw the graph of f of x times g of x, I'm going to take f of x and multiply it by the g. So I'm going to start where I can actually see one. So I'm going to start at -2. So at -2, f is 4, g is -4, sorry, g is -5. -4 times -5 is 20. I don't know. It's way past there. It's like it's up here somewhere. Okay. Then if we do at -1, we get -4 times -3, which is +12, somewhere up here too. Okay, and we go to 0. 4 times -4 times -1, +4. So that's the first one that's actually on this graph. go to 1, negative 4 times positive 1, which is negative 4. And then you're going to get connecting. Now, why is this just a line? Ooh, pretend that's straight, because that's not. Why is this a line? This is the function y equals 4, right? So f of x equals 4 is the f of x function, and g of x equals, it looks like negative 1 is the y-intercept, and your slope is up 2 over 1, so 2x minus 1. If I multiply those, I'm going to actually get 8x minus 1, correct? Or 8x minus 4, right? So it's just a line. If I had a line that was actually not a constant function like the 4, so if I had a line and another line, they would make a quadratic, right? But this one doesn't because it's a constant. So B, I'm going to instantly, because it's division, I'm going to go to where g of x equals 0 for y, and I'm going to make myself a vertical asymptote. Because that's what I'm going to do, very first thing I'm always going to do when I have a division and I'm doing the graph. So I go to where g of x equals 0, and I'm going to get a vertical asymptote. Because technically I would get 4 divided by 0, which is undefined. Right? And the numerator is actually a lower degree than the denominator, isn't it? Because the numerator is a constant, so it's x to the 0. The denominator is x to the 1. So I'm going to have an asymptote horizontally at 0. And then I draw my graph based on my other one. So I'm going to start at negative 2. So I'm going to do negative 4. Negative 4 divided by negative 5, so negative 4 or positive 4/5. So like here. This one's going to be negative 4 divided by negative 3. Sorry, negative 3 divided by negative 4, so negative 3/4. Positive, and I drew it in the positive but said negative. Good job. This one's going to be negative 1 divided by negative 4, so positive 4. So it's going to run along your, right, that. Then over here at positive 1, I'm going to have negative 4 divided by positive 1, which is negative 4. Then at 2, I'm going to have negative 4 divided by, oh, this one was negative 4/5, not negative 5/4. I think it's a negative, or positive 4/5. 2 is going to be 4 divided by, negative 4 divided by 3, which is negative 4/3. And then you're going to get your running along thing, right? So the key is to find out wherever the heck g of x equals 0 and do an asymptote first. Yeah. Whenever the denominator equation equals 0, and when that function's y equals 0, you're going to get a vertical asymptote because you're dividing by 0, which is undefined. Does that make sense? So I instantly go to where it's on the denominator equation is on the x-axis and just draw a vertical asymptote because I would technically be dividing by 0. So if you do rationals like this, it's f divided by g. But if you do it this way, you actually, because it's a fraction, what do I always tell you to do? Write them out sideways. So it'll be f of x divided by g of x. So it's actually 2x over x minus 1 divided by x over x minus 3. So this is using rationals from grade 11. Invert and multiply what you're dividing by, so multiply by the reciprocal. So you get 2x over x minus 1 times x minus 3 over x. And then you just multiply the numerators together and the denominators together, because these x's cancel, but I would never cancel them off first, because that's actually an NPV, right? So that's going to restrict your domain. So don't go crossing these x's off until you've stated your restrictions. So you're going to get 2x times x minus 3 over x times x minus 1. So my restrictions on my domain would be x such that x can't equal 0, 1, and what else? And 3. Remember with division, you have to state it for this L, the backwards L, because this x minus 3 is in the denominator here. But then when I multiply, this x is in the denominator. So if it's ever in the denominator or ever will be in the denominator, you have to state it. So if it was multiplication, you just state the denominators, right? But with division, the denominator that once was here is no longer here. You have a new one. So you've stated for every single one. So it's going to be 1, 0, and 3. What your x can't equal. And then once you have stated your restrictions, then you can cancel. Because if not, you're going to cross these x's off and you're not going to have the right to restriction, okay? And they'll assume that that's a mistake you're going to make. Now, why can I cross off this x and this x, but not this x and this x? The 2 and the x are what? What operation? Multiplied. So they could technically be in their own brackets. Anything that's multiplied together can be in its own brackets. Anything with plus or minus signs is sewn together and has to be in its own brackets. Okay? So this x and this x and this x can cancel. So you're left with 2. I pulled the cord out again. Minus 3 over x minus 1. And behind it you could say x can't equal 0, 1, or 3. It wouldn't be simplified because it says write the expression in simplest form. And if you put the 2 in, it's in expanded. You've expanded it out and it's not in its simplest form. Okay. And then I want the one where I give you h of x. No, I didn't. So in your textbook, there's a question. I thought I had it in here, but I don't seem to have it in here. Where I give you h of x and one of the other ones. Oh, I did. Go back to example 6. Back to example 6, not the right page. Okay, example 6 back here. They give you information and ask you to find certain things that are missing. So we're going to look down here at if h of x equals f of x times g of x, and f of x equals 2x minus 1, then find g. Okay? So this was like the other one where they give you an answer. So if it's h of x is this, so we're going to have h of x equals f of x times g of x. So h of x is x squared minus 2x. F of x is 2 minus x times g of x. So to get g of x by itself, you're just going to divide by the 2 minus x. And so I have g of x equals, in the numerator, I'm going to have x bracket x minus 2. In the denominator, I have 2 minus x. The x minus 2 and the 2 minus x would actually match if I take a negative 1 out. So if I take a negative 1 out of the denominator, I'm left with 2 minus x. X minus 2. Minus 2 plus x. So now they would actually match, and they would cancel, and g of x would be negative x. Because x over negative 1 is negative x. And remember, you can always check them. So take negative x, multiply it by 2 minus x, and I actually get x squared minus 2x, and I know I did it right, because h of x is just the 2 multiplied together, correct? So you can check it. Now what happens if we do division? So this one here, we'd have x squared plus 6x equals f of x, which we don't know, and g of x is negative 2x. We know we're going to divide by negative 2x, so we know that our restriction is going to be x can't equal 0, just based on the fact that negative 2x, if it's in the denominator, would be x can't equal 0. And then we're just going to multiply it up. So you could just leave it like this as well. To check it, you do f of x, which would be this, over negative 2x. So the negative 2x's will cancel, and you're left with x squared plus 6x, which is h of x. So you know you're right. Okay? At the end of the lesson is all the homework, if you want to look at it. Very last part. Yeah. It is negative 12. Just a really thick negative sign. Yeah. Nope, you're good.